we will move to the next speaker, Fraser
Thank you.
with what has astronomy ever done for us? Thank you, Joy.
You can't hear me?
Yep.
You can hear me?
Now we can hear you.
Okay. I don't know what
Fraser,
that was.
you'll have 20 minutes. I will remind you 2 minutes before your time's up.
No worries at all. Okay. Welcome. Thank you for having me again so soon after the last time. This is a bit of fun, hopefully. Don't take this too seriously. Don't think that I have any great ulterior motive, but I'm going to talk a little bit about what I've put there. What has astronomy ever done for us? The idea that we get a lot of money, many of us, not all of us, but we, as a group of astronomers, we get money. And there's a question about what we do with it and what people in the street think we do with it. I'm going to talk, although I talk about astronomy, it's a bit broader than that. If you think about this as astronomy, as space flight, as things like Hubble, the VLT, the ISS, the space shuttle, all of this is kind of in my talk in a way. I'll give you some numbers. They're on the screen there. Since 1958, so what's that, about 65 years or so, NASA spent about $650 billion. Now, this isn't aimed at NASA in any way. They are clearly the world leader, if you like, in space flight. So there's no way I'm going to be giving them a hard time. But that's a lot of money. Both Hubble and James Webb cost over $10 billion. The International Space Station costs about $3 billion per year to run. And by way of comparison, the UK's health service costs about 180 billion pounds, so about $250 billion per year. By way of contrast to that, Uganda's gross domestic product was about $40 billion. So what I'm saying there is we are spending, as astronomers, as people that are going on space missions, as people that are sending spacecraft to other planets, we're spending a lot of money, and maybe we do need to think about how we justify that. There's some more figures there. I don't want to go that into too much depth, but again, you can kind of see from there that the UK is certainly spending a lot of money on science, on physics, on astronomy, and so on. In the old days, astronomy was important because, of course, that's how we found our way across the planet. That's how people at sea would be able to find their way and avoid rocks and bits of land that they wouldn't want to crash their ships into. Nowadays, of course, we don't always see the night sky, but we don't use the night sky for navigation as much as certainly we would have done maybe 100, 200 years or so ago. I think it's easy if you talk about physics. If somebody in the street came up to you and said, you're an astronomer, you're a physicist, what do I get? What's the point of you? What do you actually achieve? CDs, DVDs, MP3 players, all kind of on their way out now, I guess. TVs, mobile phones, optical fiber, the internet, that's heavily based on improvements in understanding of physics, low energy light bulbs, medical imaging. So I think if you're a physicist, you get away pretty easily. As an astronomer, maybe it's a little bit harder. I wonder, and again, if Aviva or Gustavo can maybe throw things, because I won't see the chat myself. Does anyone know of any benefits in modern life that we can throw at people? Go, yeah, but we did this. Does anyone know of any? It's fine if you don't. I know it's, well, certainly here it's early. I guess that's the case for Europe and Africa right now. In America, it's very early. But I don't know if anyone has any ideas, if there's anything going on in the chat.
The first one is GPS.
Yep.
First intervention here.
Absolutely.
I've
sort of deliberately set a bit of a trap here because there's a few that people throw at you a lot, or people seem to think, and I was going to sort of try and dispel those myths as we go along and see where that takes us. I wondered whether anyone might throw any of those at me. I hope they would.
The pillow.
The pillow, yeah, the pillow. Okay, yeah, the pillow. We'll come back to the pillow for sure. Okay. I wondered if somebody might throw one of those at us. Well, barcodes. NASA invented barcodes, or spacesuits have Velcro or Teflon. Maybe Teflon is something to do with the space race. Maybe smoke detectors or quartz clocks. None of those are actually things that we can kind of lay claim to. People will often say about barcodes, and they'll say, "Oh, barcodes were invented by NASA to keep track of all the materials that were being built." I think for the space shuttle is usually the myth that comes around. But they predate the space shuttle by about 40 years or so. So if anyone ever says to you barcodes are to do with astronomy, yes, NASA did use them obviously on parts and things for the space shuttle, but they weren't invented by NASA, so we can't, as astronomers, grab hold of that. NASA did, however, start to invent things like the 2D matrix, which was the QR code, which when I first did this talk was a really, really big deal, and of course now exists on every restaurant table. Velcro. I wondered if somebody might mention Velcro. Was that 1948 was a good year. I've just spotted that because they invented Velcro as well, and it was invented by a Swiss guy. And Gustavo may identify with this, and other dog owners maybe identify with this as well. His dog went running off into a thick bush, and it would come back with all these things on them. I think in English we call them burrs. You can see them top left there. And this got this guy thinking that maybe this sort of hook and mesh thing was something that they could use. So it's designed originally as velour crochet, became Velcro. It's nothing to do with NASA. Yes, they use it on their spacesuits and so on, but NASA, none of us as spaceflight people, as astronomers, were involved in the invention of Velcro, unless you were involved in the invention of Velcro in 1948, in which case, congratulations. Teflon, which goes by that horrific thing there, polytetrafluoroethylene, invented in 1938. It was invented by people that were trying to make refrigerator coolant, and it was registered by DuPont in 1948. So again, yes, you will see Teflon mentioned as something that's used in sort of spacecraft design and so on, but it predates the space race by 15, 20 years or so. So we're finding things here that we maybe thought, or maybe some of you did think about these and thought, well, I'm not going to type it just because I don't want to be singled out. Smoke detectors. It's pretty important if you're on the International Space Station to detect smoke at the first sign of smoke, or ideally not to have any smoke at all. But it would be a very difficult environment to be in with any form of fire, as you might imagine. They were invented in the 60s, commercially available in the late 60s, and sort of properly mass produced in the 70s. NASA did develop one for its sort of original. Skylab was a manned mission, as far as I remember, but its manned mission in the 70s called Skylab. It did have smoke detectors on there, and they had a dial-in thing, so you could dial them up or dial them down as you selected them. But again, not designed by NASA as such. Quartz clocks. This idea of timing. You heard GPS mentioned a few minutes ago, so we'll come back to timing when we talk about GPS. But yeah, the quartz clocks were invented almost 100 years ago. So that sort of idea of really, really accurate timing has been with us for about a century now, and again predates anything that astronomers have done. I do appreciate astronomers have a role to play in timekeeping with GPS. Maybe not astronomers, but people involved in sort of that science side of things, that the actual idea of having timing. We have timing now from, I think many satellites are basing their timing on pulsars. So you actually measure where the pulsars are, and you can do it that way as well. So they're all busted. They're all things that we might claim to somebody in the street, who then might go away and look on Wikipedia and say, well, no, you're having me on here. You're trying to fool me. So let's talk about a few that are more beneficial. These are the tangible ones for astronomy. The true astronomers amongst us, whether we're professionals or whether, like Joy, we're amateurs and we're just finding out about how astronomy works. These are things that astronomers have been involved in and spaceflight engineers have been involved in that I think do benefit humanity. Now, I can almost hear Rosa in the background going, yes, but astronomy is a science and it's inquiry and it's how people understand our place in the universe and so on. I absolutely take all of that on board. But in terms of what I would call tangible benefits, actual, I can see Rosa smiling, in terms of actual benefits of astronomy to the person in the street, satellites track Earth weather. If we didn't have satellites, we wouldn't know quite as much about the Earth weather systems that are around and be able to make such good predictions. Satellites are helping us understand climate change. The satellites pointed at the sun are seeing solar activity and are maybe able to let us know about any additional solar activity, things like flares, coronal mass ejections, so giving us early warning systems there. And we're also able to track tectonic movement, the movement of the plates of tectonic plates on Earth. The key one that I think that is very easy to talk to people about is searching for hazardous asteroids, comets. We know that we lost the dinosaurs 65 million years or so ago. We know that these objects are out there because we've seen the results of Tunguska, of Chelyabinsk, and obviously going further back to Chicxulub with the dinosaurs. So we know that searching for asteroids with telescopes is a reasonably smart thing to do to help us protect our future on Earth. You could get a little bit carried away and say, okay, if we know about supernovae and if we know about gamma ray bursts, which may be linked to supernovae, that could help us predict and prepare for something like that. Now, there aren't too many stars nearby that are going to go supernovae. There probably aren't too many that are going to throw lots of gamma rays and lots of X-rays in our direction. So we're probably okay. But probably is not necessarily the best words to be using in terms of destruction of Earth, which I don't want to get to dwell on too much. But those are things I think you can see that we can say to people, say, okay, well, we're involved, broadly speaking. Telescopes are involved in understanding this. Theorists in stellar formation are involved in understanding these things. There are some more. So I mean, again, I mentioned there the asteroids. You'll go, this is the Chelyabinsk one, and this did help our cause. I think a lot of people, a lot of politicians and so on would have said, okay, if instead of this being Chelyabinsk, which you can see is not particularly built up, what if this asteroid came across Earth above Moscow or London or Paris or New York? That then things are very, very different. These are ones that we can do. I'm just checking the time. Okay, I'm not doing too badly for time. So again, I apologize. I'm not going to go through any of these in huge depth. I'm just really going to give you lists. If you want to know more, there are some links at the end. Wikipedia, Google is your friend. Wikipedia gives you some really nice things, but I'll tell you a little bit more about how to finish off on that. Things like adaptive optics. So particularly understanding how, the way astronomers design telescopes these days is really tied in very well with medical imaging, if you like. That's what I've sort of put there. So adaptive optics, CCDs, charge coupled devices, X-rays, the X-ray detectors that we have for telescopes. Well, that's reasonably similar technology to the X-ray detectors that we have in hospitals. So, there is some link there. There's links with dentistry. There are links with aerospace. Those airport scanners that you go through, some of that technology will be tied up with the technology that's being developed by astronomers, and GPS, which was mentioned earlier. I don't think Rob Hollow is here this week. I know he would be screaming at me by now if I didn't mention this one, so I will mention it just in case he's watching on replay. Wi-Fi was pretty much invented by the Australians. Okay, that's something that maybe surprises you. It surprised me, and I had to check it on Wikipedia, and it seems to be the case. They were moving around lots of data between machines in Australia. Radio astronomers produce lots and lots of data, and they wanted to move it from one machine to another, and they realized that they could do this. There have been some successful legal battles. Microsoft has been taken to court by this group in Australia called CSIRO, which is the Australian science group. They have been successful in getting a figure. I can't find out the figure, but a figure, and there are apparently still things ongoing. So Wi-Fi is one that we can kind of claim. Now, again, take a step back. If there weren't astronomers, would there be Wi-Fi? Yeah, probably, because as a species, we're pretty resourceful. Okay, so again, I'm not saying without astronomers there would be no Wi-Fi, but as you know, if you were involved in this, you would clearly be wanting to make your case for having developed it. There are some everyday items there. I will leave those on the screen for about 10 seconds and no more, just because I don't really have time to go through them in huge detail, but cameras and GPS, Sky Sports, which is our sports coverage in the UK, Dustbusters, the top left one, that's really weird. I'd love to tell you more about it. Golf balls. The trajectory of a golf ball is defined by the sets of dimples. And if you do have wind tunnel, like the ones that NASA have, then you can find out how a golf ball flies truest and furthest. There you go, but you didn't know that. Power tools. If you have a power tool, it has a torque on it. And if you put that into the wall, the power tool wants to spin the opposite way to the screw that you're putting into the wall. That's not ideal if you're on a spacecraft, because you're going to go in the opposite direction to the thing you're trying to tighten. That's probably not the best solution. So Black & Decker were involved in work with NASA to create these kind of torqueless power tools. Swimsuits, again, this idea that you can travel more quickly by understanding something about the aerodynamics, or in this case, the hydrodynamics of what you're moving through. So these swimsuits that then got banned because they were too successful were developed alongside people from NASA, bizarrely enough. Space pens. Anyone heard of the space pen? This idea that you can write upside down in a pen with a pen in space. So they exist. You can buy these for about, I forget how much it is, $20, $30, something maybe like that. Or you can buy the Russian version, which is a pencil, which they don't use in space. Now, you might think that they would use a space pencil because it would be cheaper than a space pen. Rosa's laughing and shaking her head. Why wouldn't they use it then? Why wouldn't they use a space pen? A space pencil, you don't know. Honestly, I know this is lighthearted, but I'm not making this up. This is real stuff. The Russians use space pens. They use the same space pens that NASA use. The reason being, if you had a pencil, if you snap the end off, I don't have one here, but if you snap the end off, you've got a piece of graphite and you're in space, and this little bit of graphite is floating around your spacecraft and is probably going to find itself lodged in a switch somewhere, and that's going to turn a switch on or off that shouldn't be on or off, and that's not going to be ideal. So the Russians use the space pens. This stuff, how much time I've got? Very little time left. Okay, I'll keep going until Aviva tells me to just stop. Aerogel. Google aerogel. If you've never come across the idea of aerogel, Google it. 99.8% of this material is air. It's called frozen smoke. You can see the image at the top right there of a piece of aerogel with some matches on top and a lit blowtorch underneath, and the matches aren't catching fire. So it's a really, really good insulator. It's a very low density solid, and it's the solid that they use to catch dust in cometry and sort of planetary missions. Robotic surgery. The idea of robotic surgery comes from the same technology as the Canadarm, the Canadian contribution to the space shuttle, which is this robotic arm. It's the same principle that's going on with robotic surgery. Water filtration. I think this is a really important one. I think the way our planet is going, water is becoming the most precious resource on the planet. Outside of, well, I was going to say outside of Europe, but let's say outside of Northern Europe and North America, and that's about it. Everywhere else is wondering about water. Let's not go into detail, but the
Fraser, you
International
have
Space...
2 minutes left.
No worries, Aviva, I can finish in 2 minutes, no problem. The International Space Station does not have water trucks going up to it to deliver water. The water that is used on the International Space Station is recycled. I'm not going to go any further with that, but you know what I'm saying there. You need to recycle that water in a healthy way. So the water filtration aspects that NASA has been able to develop, and thinking about the Martian analog missions as well, things like that, where you don't have an unlimited supply of water, it's important to be able to filter your water well. That, I think, is my final slide. They're all the other things. They're all the other ones that I didn't have time to talk about today. And I apologize. I know there's a lot of writing on that slide, but the point of all that writing is to show you just how many things there are that spaceflight, satellite technology, astronomers can claim. We can claim these. It's a little bit spurious in parts. I know that you're not going to convince too many people with some of these things. But thank you very much for listening. I will leave it there. There are my sources if you want to find out any more about any of them.
Okay, thank you, Fraser. Thank you for this the talk. Thank you for pointing everything for us. And for me, okay, before I ask for the questions from the participants, I just want to make a short comment that everywhere I go when I teach astronomy, the students or the just general people, they always ask what's the connections between astronomy and everyday life. And now you point so many things for us, and it will be useful in my presentations everywhere. Thank you. So we have questions here from Joy. I have a quick snapshot of your last slide. Interesting things there, great presentations.
Thank you.
Is there any other questions?
Yes,
Do we have questions?
I have a comment. No, it was interesting. The two comments actually. The first was when you start a presentation mentioning the amount of money invested, and it's like 8 billion, I think, and that might scare people. Say, "Oh, that's a lot of money," but it's interesting to compare with other spendings and just the obvious comparisons with military, and it's like roughly 10 times more. I know it's going to increase probably. So that's and other interesting figure I was checking for the UK was the debt interest. So that's like money that is paid to investors, and it's even larger. It's about 116 billion. It's 10% of the budget. So,
thank you for reminding me about that. Yeah.
So it's people always. I think it's always interesting to make such kind of comparisons to not lay people, so they can see that there much more money
Sure.
going. And then back to your list, you know, you focus it on the material things, right? But there are the intangibles, and that's like human resources and knowledge, and that's, I think, even surpasses the material things that are listed, which are also always very important. But you know, there have been studies that for every dollar invested in the Apollo program, like there was $7 in return. So it's really a nice presentation compilation. I think it would be very useful for everyone.
Good, thank you. Yeah, just to come back on the money side, don't forget a lot of that money that NASA, European Space Agency, the Japanese, the Indian agencies spend on astronomy or on spaceflight, that's going on people's wages. And I didn't get a figure. Maybe that's a figure I should add in at a later date, is how many people are employed directly or indirectly by NASA. Because again, that's, you know, as you say, if you give somebody a good salary, they spend that salary in their local community, and that develops wealth. So yeah, absolutely.
Okay. Yes, there's final comment here by Ad that scratch resistant lenses would be a wow. I agree. A wow. Would be amazing. A wow.
Oh, well,
That will be
They
amazing.
exist. The material that the people that do the spacewalks have on the front of their visors, that's the same sort of thing that we use in contact lenses.
Thank you. I think we need to move to our